We are in the Scholar series for ABM. In this, we are covering the important objective questions, important theory, as well as the important numericals. So follow the series completely. Okay, let's start. A bank calculates that its individual savings accounts are normally distributed with a mean of 2000 and a standard deviation of 600. If the bank takes a random sample of 100 accounts, what is the probability that the sample mean will lie below 1900? This is a bit difficult to understand. Everyone pay attention. Huh? Everyone pay attention because very important part. Let me draw the line over here. Very important part. Understand, for this you need to know this normal distribution curve. Let me show you. Suppose if this is the normal distribution curve, okay? This one. So what is given in this problem? And say this. Mean is given as 2000. So this mean means what? This mean always lies at the center. This is the mean. And this is known as population mean. Mu, this is called mu. That is 2000 population mean. Always remember, what are we doing actually in this numerical? We are doing some sample over here, doing something on the sample, and then applying it to the entire population. Entire population we are applying it. Okay. So this is the meaning. This is the problem actually. Doing something on the sample and applying it to the population. Got it? Now what is it given? Normally distributed. That the savings accounts are normally distributed. What do you mean by normally? It means the population is normally distributed. It means that the bank is having some savings account. Let me show you over here only. See this. This is the population and this is the sample. So this population means for entire savings accounts of the bank. Savings accounts of the banks is the population. Now, do you know how many savings accounts are there? Have they mentioned it? That the bank has 1 lakh savings account, 50,000 savings account, something like this. Have they mentioned? Nothing. So it means what? This savings account becomes this becomes an infinite population. Infinite. Okay? It becomes an infinite population. Got it? Now, as it becomes an infinite population, the formula for standard error changes. Get this, huh? Formula for standard error changes. Now, always while solving this numerical, first step which you have to find out is whether this is finite or infinite population. Because if you have infinite population, then the formula for standard error psi x dash we write it. Okay, so standard error equals to standard deviation psi upon root of n. That is the formula for infinite. Okay, I'll write it. And if it is a finite population, means known population, 1 lakh savings account, 50,000 savings account, then it becomes what? Same, psi upon root of n. Psi means standard error, standard deviation. Standard deviation upon root of n into square root of capital N minus small n upon capital N minus 1. This is for finite population. Okay. Now look at this. In the problem, whatever is given. What is given in the problem? Population is given as 2000. Okay, no, not population. Mean is given as 2000. See this. Mean is given as 2000 and standard deviation is given as 600. 600 for this population. So standard deviation means how much the answers deviate from this mu. So that is given as 600. Now what about the sample? In the sample they have given that the bank takes a random sample of 100. So 100 is the sample size. Small n is given as 100. Okay. Now have they given anything else now? Second part, what have they given? They have asked you probability of sample mean will lie below 1900. So what do you mean by below 1900? Look at this. This is 2000. This is mu is 2000. So on the left side will always be less than 2000. So 1900 will lie over here somewhere, right here. So what do we want? We want below 1900. 1900. So we want this area below 1900. Okay. This area below 1900. This is the basic answer we require. This area we require. Now how to find out the area over here? Now for finding out the area, let me give you some hint. See this. In exam also, they'll give you this normal distribution table. This table will be given to you. And now what have you to check? The upper figure over here. This figure is very important. If this figure is given as this way, it means what? It means it is starting from here, this point, to wherever you go. It's moving like this on the right side. If they give you the figure like this, and the red part over here, this red part over here is starting from here only, here only. If they give you like this, if this figure red part is like this, only this part, okay, then what does it mean? In that case, it means it is starting from 0.5. So when it starts from 0.5, the figures will be different, the answers will be different. So if they give you from this, the majority of chances you'll get it from in this, because this normal distribution table is used throughout the world. Starting from 1, because this total area is called as 1. This total area is 1. Okay. This half area is 0.5. See here, I'll write it over here. This is 0.5 area complete, and this is 0.5 area. Okay. So now what have they given? They have given that we want it below 1900, so we want this area. So for finding this area, this means what? This is a probability. The answer which you get is a probability only. For getting this probability, you need to find out the z value. Without z value, you can't get the probability. Without z value. Okay. So now look at this numerical. Firstly, what have you to do is you have to find out the standard error first. Standard error is given as psi upon root of n, because this is an infinite population. So psi upon root of n. What is psi? Psi means standard deviation. Here it's given 600. 600 upon root of n, root of 100. So 600 upon root of 100. So what is the answer? Root of 100 is what? 10. So 600 upon 10, you are getting it as 60. So my standard error is 60 now. Clear? Simple. My standard error is 60. Now, up till now, everyone has understood this. Type yes in the comment section if you have understood it. Has everyone understood this? Yeah. Okay. Done. Now what we do, the next formula which we get is Z. How to find out the Z? See, the Z formula is like this. Z equals to 1 upon psi x bar. This psi x bar means standard error into, now look at this, x bar minus mu. Now what is psi x bar? Psi x bar means this, right now what you have got. So 1 upon 60 into, what is this x bar? X bar means what is asked. Here, what is asked over here? 1900. This is x bar. This is x bar. Okay, so it will be 1900 minus what is mu? Mu is given, just now we saw it, 2000, right? So minus 2000. So do it now. 1900 minus 2000, I think so. Are you able to see this? Let me see. Yeah, you are able to see this. Okay, so I'll draw a line over here now so that I won't write anything over here. So now, so do it. Ignore the signs here. It is minus 100 upon 60. So ignore it. Minus sign is okay. You will take this as modulus. Okay. So it is 100 upon 60. So what is the answer you are getting? 100 upon 60. Everyone. What is the answer you are getting? 100 upon 60. 100 divided by 60. So the answer which you get is 1.66. 1.66. Okay, 1.66. So this is what Z you are getting. This is the answer which you are getting is of Z over here. Everyone, see, I'll explain this numerical 2 times, because what happens, many of the students are asking me to repeat it. See, I'm seeing in the comment section. I'll explain it, don't worry. I'll explain it again. Okay. So Z equals to 1.66. Now what do you do now? See here, up to Z, have you got it? Repeat it. See here, repeat it. I'll repeat it fast now. See here, what we do, this numerical will be given to you in exam. So your first target is find the difference, this sample and population. Find everything between, divide between this. So first find the population. Population is what? Do you know finite or infinite? It is infinite, right? Infinite. Keep it simple. Infinite. Once you get it infinite, immediately apply what? The standard error formula. And write down the values, whatever are given. For population, the value is given as mu. Mu is given as 2000. This one. Then standard deviation, we write it psi like this. Psi. Psi is given as 600. Then on sample side, what is given? N, small n. Sample size is given 100. Then what is given about the sample mean? What about the sample mean? You don't know. So we'll call this as x bar. X bar is given as 1900. So these are the four values you are having. Whenever you get such a problem, you firstly divide it into these four parts. Then apply the formula for psi. Psi x bar. This. Psi x bar. Psi upon root of n. If it's a infinite population, apply this. Psi upon root of n. 600 upon 10. 600 is psi, standard deviation, root of n, root of 100. So 10, so 60. You got it, psi x bar. So this is known as standard error. Standard error. Okay. Now once you get this standard error, what you do next is find the z value. What is the z value? Z value equals to 1 upon psi x bar into x bar minus mu. This formula you have to rectify, learn by heart. 1 upon psi x bar into x bar minus mu. Okay. Now all the values you are having. 1 upon psi x bar you are having. Psi x bar is 60. X bar you are having 1900. Mu you are having 2000. Okay. So now do it. 1900 minus 2000, that is minus 100. Ignore the plus minus sign. So take it plus only. And this 60. So 100 upon 60 is 1.66. Up till now over here, got it now, everyone. Now using this z value, we have to find out the probability. Now this table will be given to you in exam. And in this probability distribution table, remember, you have to check what this image is given. If this image is given from the starting, then it means your complete area of 1 is to be taken. This complete area of 1, complete area is known as 1. So if it is given, then you will be taking this complete area of 1. If it is given, this red mark is given only from half, okay, then you have to take only half. You have to take it from 0.5. Do all the calculations using 0.5. Now what am I saying? I'll explain you. Let's find out this z value first. Let me expand this. What was that z value? 1.66. So first find out z. See here, z is like this. How do you divide this z? Divide this z like this. 1.6, 1.66. So make it two parts. 1.6 over here and 6 over here. So this 6 will be checked in horizontal. This 1.6 will be checked in vertical. Now go forward. So vertical now. 1.6 first. 1.6 over here. And then other 6 is over here. See this 6. Match this 0.06 and 1.6 over here. It is coming to 0.9515. Look at this. Everyone is getting this 0.9515. Let me see how many of you are getting these answers here. Okay. Now, those who have not heard, kindly give me the answer for 1.66. 1.6 and 0.6. So give me the answer. It is in the comment section. Everyone in the comment section. It is 0.9515. Got it? This is 0.9515. Look at this. 0.9515. Everyone got this? Clear? 0.9515. So my probability over here is, now look at this. This is not your answer, but probability equals to 0.9515. Okay, but this is not your answer. Look at this. What do we want? Yeah. So now what do I want? My probability value is, probability equals to 0.9515. Okay. But do I want this 0.9515? No. Why? Because what am I getting? I want it below this area. And what is it given over here? It means when now you'll have to search. Now you'll have to think. This area of 0.9515 means from here. Okay. And I wanted what? Below this, from starting up to 1900. So this area 1900. So this 0.9515 area means this area, this complete area. Okay. So which area is it covering? And I want, remember, below 1900. So I want it on the left side. This area only I want it. This on the left side of this line. I want that. Because I want below 1900. If I would have required above 1900, then I would have required this area. But I want below 1900. So I require this area, this part. So when I require this part, and what have I got? 0.9515 is the answer which I've got. It means what? It means this area only I've got it. So my answer over here is luckily the same, 0.9515, because I'm counting it from the left side and I've got the area of the left side only. So that's why my area, my probability over here is 0.9515. If they would have asked you that, give me the area for above 1900, then what would have you done? Above 1900, okay? Now let me show you that also. Above 1900, what would you have done? See here, this total area is 1. Now look at this, everyone. This total area is 1, right? Out of this, 0.9515 is below 1700 over here, let's say, because this is 1 means 95% you are covering. So this all area is below 1900, okay? Now if they would have asked me that I want this above 1900, so this total area is 1 minus 0.9515, 0.9515. If they would have asked me this area, then this would have been my question mark and this would have been my answer. But now they have asked me what? They have asked me below 1900. So I am wanting this area only. So my answer is correct over here. Luckily it is 0.9515 only. Okay. Got it, everyone? This is the way this numerical is to be solved. Not that simple. It's really difficult. You have to understand this probability distribution table correctly. And for that you need to join the classes. Okay. Yeah, paid classes. Because there I am teaching you all these numericals again and again, many times. Everyone subscribe to Officers Adda 24/7 YouTube channel. In this channel, you will be getting number 1, free YouTube series on all the subjects of JIB and CIB, all. And whatever is free, you should grab it, isn't it? So that's why subscribe to the channel, click on the bell icon immediately. Okay? Share it with your friends. Now some theory part. An interval estimate. Now this is regarding the estimation chapter. An interval estimate is the range of values used to estimate the population parameter. What do you mean by this? See here, you want this population parameter. Always remember this parameter word is always attached to population. And for statistic sample, it is which word is attached? Who can give me the answer? Comment section. For sample, which word is attached? The word attached is statistic. Always remember statistic. For sample, statistic word is attached, and for population, parameter word is attached. So interval estimate is the range of values used to estimate the population parameter. It indicates the error in two ways. The extent of its range means how far can this go. Means what? Suppose if I tell you today's India's score will be what? Suppose if I ask you this question. Suppose let's say there are matches going on now. India is, let's say, playing, and I ask you in 50 overs, or now let's say 2020. In 20 overs, what will be India's score? If I ask you this question, then what does it mean? Can you give me the exact score? In 20 overs, India will score 197. You can't give me. What will you give me? You will give me a range. Around India will score around 170 to 200. So this is known as range. Extent of its range. Now if I give you, tomorrow I will give you this range. India will score, I think so, 0 to 500. Within this range it will definitely score. You'll say what a foolishness it is, right? Because if I am telling you 0 to 500, definitely it will be between 0 to 500. So the answer should be somewhat logical. By the extent of its range. So range is important over here. Extent of its range. Okay. So what range are we talking of? That is important. Got it? So that's why, so this extent of its range and by the probability of its true population parameter lying within that range. So within that range, if I give you this range at 0 to 500, definitely India will score between 0 to 500. But if I give you the range like India will score between 470 to 500, now this is the accurate range. So my answer will lie somewhere in between. If it lies, then I'm accurate. If my answer doesn't lie over here, it lies somewhere in 100 only, then I'm far beyond this range, right? So extent of its range and the probability of the true population parameter lying within that range. So actually the answer should lie within this range. Okay. So that is a good interval estimate. A sample statistic is used to estimate the population parameter is known as estimator. This sample statistic is known as estimator. Okay. Means whatever statistic we are using, mean, mode, median. What is the statistic? Statistic can be many things. I'll give you simple ones. Mean, mode, median. Right? These are all statistics. That is used to estimate a population parameter is called as estimator. The sample mean X can be estimator, an estimator of the population mean P. And the sample proportion can be used as an estimator of the population proportion. So it mean X, sample mean can be used as the estimator, and the sample proportion can be used to estimate the population parameter. So what does it mean? I'm using this mean, calculating this mean from the samples and using it for population. We can also use the sample range to estimate the population range. So let's start with the simulation exercises. Simulation, remember, it is the easiest chapter in your complete ABM. But even though it is easiest, don't take it lightly, because there are certain questions related to the simulation exercises which are asked. So focus on them very properly. Let's start. Which of the following statement regarding the simulation is correct? So now you have to find out whichever is correct. Always remember, in exam you have to focus on what is asked, whether correct is asked or wrong is asked. If they want wrong, then you have to click on correct and the wrong one. Okay. So what is the one? Let's see. First one. Simulation is a way of studying effects of changes in the real world through models. So is simulation the same? B. Simulation is an imitation of some real thing or the process. C. In simulation, it is tried to imitate a system or environment in order to predict the actual behavior, and all of the above. Now, firstly, understand what is simulation. Simulation means, suppose when you're, have you seen simulation anywhere? Whenever you go to, let's say, any new construction flat, suppose if you want to buy a new flat, whenever you go to buy a new flat, the building is not ready at all. Many times they just show you some prototype, some model which they prepare. So what is that model? That model is a smaller image or smaller 3D image of what the real building will be, right? So this is basically the simulation. Similarly, in simulation, whenever you go for admission in any college, what do? Do you go and check this college practically? No, you check on the prospectus. What is that? That is a sort of simulation. It will give you the image of that college, right? So that is simulation. So now which of the following are correct over here? Which of the following statements are correct? Yeah, they are. Number one. Yeah. Which of them are correct? Simulation is a way of studying effects of changes in the real world through models. That is correct. Simulation is the imitation of some real thing or the process. So that is also correct. In simulation, it is tried to imitate a system or environment in order to predict the actual behavior. This is the most important one. Okay, because here we try to imitate a system or environment. Actually, we try to, in finance also, we use the simulation. We see various scenarios, and based on those scenarios, we create the various effects of those scenarios. Okay, So in simulation, it is tried to imitate a system or environment in order to predict the actual behavior and all of the above. So the correct answer is D, all of the above. Okay. Everyone answer in the comment section. Acting out or mimicking an actual or probable real life situation or event to find the cause of the past occurrence or to forecast the future effects of the assumed circumstances or factors is called as, what is this? This is on the similar lines of that earlier question, isn't it? Acting out of mimicking an actual or probable real life situation. What did we say about the simulation? Same thing, isn't it? To find out the past occurrence means what had happened in the past, or to forecast the future effects. Now this means that considering the various scenario analysis or factors is called as simulation, linear programming, probability, regression. Now look at this. Simulation you might have guessed the answer by now. Type in the comment section. Linear programming. Programming is altogether a separate chapter. In LPP, what do? We study various linear equations. We try to bring everything into the linear equations and then we try to study them. Probability is totally different. There are three types of probabilities, right? Bernoulli, this binomial and Poisson. These are the three main probabilities for your CAIIB. Kindly follow the this probability lecture also. Regression and correlation, again different chapters. Regression and correlation are related to two elements, the relationship between the two elements. So this mimicking an actual probable real life situation, what can be the answer for this? The answer is simple, isn't it? Let me see in the comment section. It is A, right? Got it? Simulation can be used to, means why do we use the simulation? To find causes of the past occurrences only. To forecast the future effects of any occurrence only, means only this. Find the causes of the past occurrence and to forecast the future effects of an occurrence. Neither to find out the causes of past occurrence nor to forecast the future effects of any occurrence. Now obviously D is not the answer, okay? Neither is not the answer. Now only you will get confused over here whether to type A or B or C. Again you will get confused between B and C because A also past occurrence only, that is not the right answer. So you will get confused between B and C. Now type in the comment section, let me see. Okay, let me see everyone. The answer is, yeah. Is it B or C? The answer is C, correct? The answer is C. Because it is used for past also as well as to forecast the future also, right? So that C is the answer. Simulation is appropriate where? Now look at the options. Where? Size of the problem makes the size of other techniques difficult or impossible. Complexity of the problem makes the use of other techniques difficult or impossible. Problem is impossible to be solved. So where do we use the simulation? In which case? Size of the problem makes the size of other techniques difficult or impossible. Means what? Suppose imagine I have to do some changes in my software, banking software. If I have to bring totally new software, so is it possible for me without testing just to bring the whole software new, and one night I'll bring the whole software new in the bank and tell everyone to operate on it? It's not possible, right? That will create a chaos. That is the meaning of this first sentence. Size of the problem makes the size of other techniques difficult or impossible. I can't implement the software, new software in a bank because without telling anyone or without doing the testing. So doing the testing is known as simulation. In simulation, what do we do whenever we test the software? We create a dummy environment, right? And in that dummy environment, we do the all the checkings, correct? Complexity of a problem makes the use of other techniques difficult or impossible. That is also a point. See here, important part over here is size. Second is complexity also, because finance is the most complex field in this world, right? Because complexity. Suppose again come back to the same example. Suppose if you go for this software changing the software. So that is so complex. There are so many fields in the banking, retail, corporate, then we have mutual funds, third party products, then contingent liabilities like LCs, bank guarantees. So that's why these are just the four which I have told you. There are almost 7 to 8 fields. So these fields make it difficult for change of software at abruptly. Problem is impossible to be solved. Is there any problem which is impossible to be solved? Now you answer. Is the answer A to 3 all? B, A and B, 1 and 2 only? C, 1 and 3 only? And D, 2 and 3 only? So what can be the answer for this? Everyone? Yeah, answer is correct. Type in the comment sections. Yes, the answer is this B, 1 and 2 only. Because 3 can't be the answer. You can't have any problem in finance which is impossible to be solved. Okay. Simulation can be used, number 1, with traditional statistical techniques, with traditional management techniques, without the traditional statistical techniques, without the traditional management techniques. Now this is a bit easy to understand, isn't it? With traditional statistical techniques, with traditional management techniques. So it can be used with both of them. Without traditional statistical techniques. So do I understand this here? Can be used with traditional statistical techniques means what? Are the statistical techniques in my regular working required to be added or to be supplemented by simulation? Or is simulation required to be supplemented by my traditional techniques? Can simulation work without my traditional statistical techniques? Can simulation work without my traditional management techniques? So which one is correct? Only one is correct. Only two is correct. 1 and 2 are correct. And 3 and 4 are correct. Which one is correct over here? Now this is a bit tricky one. Because if you get such question in exam, you will definitely get tricked over here. Okay. Now think and type in the comment section. Let me see. Okay. I'm seeing the correct answers are here. It is this 1 and 2. 1 and 2 are correct because remember in finance nothing is independent. Nothing is independent. You have to always use everything in connection with the other one. So traditional statistical techniques, traditional management techniques, these are to be used in connection, in togetherness with simulation. You can't have anything individually working over here. Okay. So 1 and 2 both are correct. In which of the following simulation can be applied? So where can the simulation be applied? Air traffic control, queuing, and aircraft maintenance, assembly line scheduling and inventory reorder design, railroad operations and facility layout, and all of the above. Simulation means what? What did we study about simulation now? Simulation was basically this mimicking the actual life situation in the form of a prototype. So where can you use this? You can use in all of these. Air trafficking control, you can use it. Assembly line scheduling, you can use it. Railroad operations, you can use it. So answer is D, all of the above, right? Now some theory, last part of this topic, theory, forecasting technique. Now forecasting technique, there are two methods. Auto-regressive, three methods, not two. Auto-regressive, then moving average, and last one is ARMA, combination. So what is auto-regressive? In auto-regressive model, we forecast the variable of interest using linear combination of the past values of the variable. Look at this, linear combination, okay? Remember this word which I have highlighted. In exam, auto-regressive model will have this word linear combination. The term autoregressive indicates that a regression of the variable against itself, against itself, okay? The AR part involves regression of the variable on its own lagged values. So lagged means what? Past values. These two sentences are same, against itself and lagged values, okay? MA means what? Moving average. In this time series analysis, moving average, also known as moving average process, used for modeling univariate time series. See, this univariate word will be there in moving average. It involves modeling error term as a linear combination of error terms occurring contemporaneously. Means what? What is this contemporaneously? So big word. This is latest one, latest. Whichever is the latest will get the highest weightage and various times of the period. So from exam point of view, remember auto-regressive means linear combination and own lagged. Moving average means what? Univariate, and if they give you this word contemporaneously, then it is MA. And now it's a combination, ARMA. Third one, ARMA model or auto-regressive moving average model. ARMA model describes a time series in terms of two polynomials. Remember, again underlined words, two polynomials. The first of these polynomials is auto-regression and the second is moving average. So it's a combination. The model is a combination of AR and MA model. In this model, the impact of previous lags and residuals are considered to forecast the future values of the time series. Okay, future values. So it is a combination of these, and previous and residuals are used to give the future values. Now these are in the short I have given. Auto-regressive, previous time steps, and next this uses observations from previous time steps as input to the regression equation to predict the next time step. Moving average MA states that the next observation is a mean of every past observation. Auto-regressive model uses the time series data to either better understand the data set or to predict the future values. So importantly, what you remember, these earlier two slides are very important from your exam point of view. AR is linear and own lagged. Moving average is univariate and contemporaneously. Then ARMA model is combination of these two. Okay. So and this line is important. Impact of previous lags and residuals are considered. Okay, previous lags and residuals both. Now the last, which I was telling, why do we have this x multiplied by 2? Okay. Now this slide, let me check if I am having it over here.
Why do we have to multiply this x by 2 over here? Okay, let me see. I had prepared one slide for this. Let me see if I'm having it. No, 1 second. No, it's not there. Okay, I'll tell you. Why do we multiply with this? Forget this slide. Okay, what is there difficulty in it? See here. The problem over here is why do we multiply this by 2? Because look at this. X, whenever we have even numbers, even. Okay, what was the x values? Minus 1.5, something like this. It was in points. So whenever it is in points, it's difficult to calculate. In points, it is very difficult to do the calculations. So if I multiply by 2, then what happens? 1.5 becomes 3. So now this is easy. And that's why we multiply by this x by 2. Whenever we have even number of elements, we multiply this x by 2. Why? Because taking the x values, even if you take the same value without multiplying, then also it won't make much difference. But the problem is that the difficulty level in calculations on the calci also, checking the point and doing the calculations is difficult part. So if you have even simple natural numbers, it's very easy to calculate. Okay, so that was the reason why we multiply this x by 2. Okay, so that was the topic. We'll stop over here now. Okay.
Firstly, sampling distribution. What is sampling distribution? You must understand that first. Sampling distribution is a process used in the statistical analysis in which the predetermined number of observations are taken from the larger population. Now, important word over here is predetermined number of observations. Remember this by heart. What happens? I must know how many samples I have to take. If I don't know that, then it would be of no use for me doing some sampling. I'll go on doing the samples. How many numbers I don't know. I'll take 500, then 1000, then 1 lakh. It won't end. So you must first decide where I have to stop. So predetermined number of observations are taken from the larger population. The methodology used to sample from a larger population depends on the type of analysis being performed. Now understand this. Methodology means what? Here it means what type of sampling should I do. There we come with the topics of these random sampling, all the various types of sampling. I'll take them. Okay. So got it. Firstly, the concept. Okay. Okay. Now for a few things you need to understand. Sampling. Now suppose if I tell you to take some tea. Okay. I'll give you a cup of tea and ask you whether it's hot or not. What will you do? Will you take the whole cup of tea and drink it immediately to check whether it's hot or not? No. What will you do? You'll just take a sip of the tea. Sip, right? Hot. So if that sip is hot, it means the whole cup is hot, right? The whole tea is hot. That's the basic logic of sampling. I'll select those samples which will be indicative of the full population. Suppose if this is a city of 1 lakh, okay? Complete 1 lakh. If I do the sampling of whole 1 lakh, it is called a census. Understand the word. Census means when I do the sampling of each and every person. But when I am doing sampling as such, sampling word, when I am doing the sampling or survey, there I'll take the samples and I'll do the survey of those samples. I won't do the survey of all the population. Okay, got it? Simple. This is what the concept is here. You need to understand the concept first. Okay. Now look at this. Some important points over here. There are two parts. One is population and second is samples. Here, as I've showed you over here, this full circle is known as the population. 1 lakh people. And the samples which I take are known as, these points are known as samples. So this is the population as a whole and then we have sample. Now what are the terminologies used for the population and the sample? Look at it. Okay. Definition of population. Collection of all items. Full population. Suppose 1 lakh persons, as I told you over here. 1 lakh is the population of a city. So if I do the full population or survey of full population, it will be called as what? Then it will be called as census. And this is known as population. So it includes collection of all items. And here, part of the population, some part. Okay. What are the characteristics? Suppose if I take the mean, mode, of population, it is called as parameter. Suppose if I take the mean mode of sample, it is called as statistic. See here, mean standard deviation of population is known as parameter. Mean standard deviation of sample is known as statistic. We have various other statistics and these parameters. Mean, mode, median, all these are parameters as well as the statistics. Okay. Now how they are defined? Look at this. Size is always given as capital N is always for population. Small n is always for sample. Mean of population is shown as mu. Mu. Remember this is called as mu. And mean of sample is always shown as x bar. This you will see it when I will take the problems. Okay, there it's very important. Standard deviation is given as psi. This is called as psi. And here standard deviation is called as psi. But I'll tell you one more thing over here. Whenever I am taking anything for the sample, it is generally called as standard error. Remember this. If I have standard deviation for population, for my sample I have standard error. Okay. And we generally write it. You will see this when I solve the numerical. Psi dash. Okay. Psi dash. Okay. Now what are bias samples? Bias means what here? We always say, no, this person is biased. My boss is biased. This is a general statement given by us, right? Boss is biased towards some employees. Right? You have seen this? Suppose the parliament is debating on the women's bill. You are asked to conduct an opinion survey. Because women are most affected by the women's bill, you interviewed many women in different cities and towns and rural areas of India. Then you report that the overwhelming 95% are in favor of the reservation of the women's bill. Now that is the bias sampling. If you ask only women about the women's bill, they'll definitely support it. Generally, that's a tendency. Okay. So that's the basic bias sample. So in here, what do we mean to say is that the population should be equally divided. If you are asking for those who are in favor, you should also ask for those who are not in favor. Okay. Otherwise, it becomes a bias sample. Now look at this. This sampling is of generally three types. 3 or 2 also we call it. Probability, purposive, and third is no rule sampling. Now no rule is generally not asked in exam. Probability and purposive is asked many times. Purposive is also called as non-probability. It is also called as judgmental. See here, I'll write the words over here. Okay. It is non-probability also they call it. Non-probability. I'll just write non-prob. Okay. And next one is judgmental. Judgmental. Okay. That is also the another name to purposive. Now probability samplings are of 4 types. Simple random, systematic, stratified, and cluster. Now we'll study each one in detail. But before going ahead, I'll just give you the short idea about this. Simple random and all those. Okay. Understand one simple logic of probability. Probability sampling means that sampling in which every element has got an equal chance of getting selected. Equal chance. Okay. So every person, every individual, every sample will have equal chance. Now it is of 4 types. Suppose if I say in a class of 50 students, any 10 students, that becomes simple random. If I say every 5th student, means what? I'll tell them to stand in the row. I don't know. I'll close my eyes. I won't tell who will stand where. I'll close my eyes and tell them stand in the row and every 5th student come out. So that is all. That is known as systematic. Suppose if I divide that class of 50 students into marks, those who have got 40 to 50% stand here, 50 to 60 stand here, 60 to 70 stand here, and so on. So that will be called as stratified. I am creating strata, I am creating levels over here. Okay. And last one is cluster. Suppose if I tell them, those who are from Maharashtra stand here, those who are from Delhi stand here, those who are from Tamil Nadu stand here, those who are from this any state stand here. Okay. So this is generally cluster. Cluster is generally related to region. Okay. Now one important point I'll give you over here only, stratified and cluster. Within the same strata, they have similar qualities. Means what? 70 to 80% student The student who is having the range of 70 to 80 will think similarly. They'll think similar to each other. Versus students who are having the marks 70 to 80 and the marks of 40 to 50. Their ranges will be different. Thinking ability will be different. So that's what is meant by stratified. 40 to 50% student will always think of passing. 80 to 90 will always think of scoring. So within the same strata, they'll have similar qualities. Within different strata, different qualities. Reverse is the case with cluster. Within the same cluster, there is a huge variety. Now somebody is from Goa. So in Goa also there will be a student of 80 to 90%. There will be a student of 40 to 50%, right? So within the same cluster, there is huge variety. It's exactly opposite of this stratified. Within different clusters may have similar qualities. Different clusters may have similar, means what? Goa will also have some student who is 40 to 50 and MP will also have some students who is 40 to 50. UP will also have that, right? So within different clusters, we may have the students of similar categories. That's what is the difference between stratified and cluster. This question comes every time in the exam, okay? Now, more about this non-probability. See this, I'll tell you later also. I'm having a separate slide on this. Convenience sampling, consecutive sampling, quota sampling, purposive sampling or judgmental, and snowball sampling. I'll give you a separate slide on this now only, okay? And then we'll study each one. Now simple random, we'll go in details now for probability because that's very important. Simple random sampling selects the samples by methods that allow each possible sample to have an equal probability of being picked and each item in the entire population to be included. Means what? Each possible sample to have of having equal probability. Means what? Just now I told you. Any 10 students from the class of 100 students. Any 10. So everyone has got a chance. So that's what is meant by simple random sampling. Each possible sample, see this, each possible sample will have equal chance. Very important part over here. Okay. I'll mark this. Hold on. Each possible sample, this one, has an equal probability of being picked. Okay. And each item in the entire population to be included in the sample. Correct? Now let's look at this for simple random sampling. Suppose if I give you this example. There are 4 teenagers, A, B, C, D. Any boys, you, anyone we can consider. Now I have to select a group of 2. How will I select? Group of 2 can be selected in these ways. AB, AC, AD, BC, BD and CD. This is the only way which I can select, right? This you are having a separate topic of probability. There we'll study this again. Okay. So these are the groups I have selected. Now the question over here is probability of drawing these samples of 2 people is same as below. So means what? Suppose if the probability of selecting any 2, this BC or BD or AC, I close my eyes and I tell them to stand in these groups. And what happens? I close my eyes and select any group. Then what is the chance? Suppose if I want to select BC. Out of these 6, BC can be selected in only one way. So look at this. Probability of BC is 1 by 6. Similarly others. CD can be selected in only one way. So if you want to select the group, the probability is 1 by 6. Now look at this. This is separate. Suppose if in this group I make them to stand in group of 2s. And what is the probability? That I'll select A in this. Any group which I select, what is the probability that I'll select A? Single person. Now look at this. A can be selected in how many ways? AB, AC, AD. In all these A's there. So A can be selected in 3 ways, right? 1, 2 and 3. 3 groups. Out of how many? So 3 divided by 6. Now look at this. Very important part. This becomes a technical part. Okay. So A can be selected in 3 ways. 3 ways upon total 6. So 3 upon 6 is 1 by 2. So here comes the answer of 1 by 2. This typically is related to probability required upon sample size. means success. I'll write it over here. Probabilities formula is like this: success upon sample size, SS. Okay, we'll study this when we study probability. If you want to write A, B, C or D of on 4 identical slips of paper. Now here comes the next topic of this within the same random sampling only. The next topic which comes is sampling without replacement and with replacement. Now this you common sense you can understand it. Without means what? I'll take 4 papers, 4 chits A, B, C and D. Okay. And slip of papers, fold the papers, randomly pick any 2. Suppose if I select any 2. And then what do I do? While picking up 2 slips, we may pick one by one and keep it away. Pick another from the remaining 3. Now remaining 3, what does it mean? Once I pick one, I won't keep it again. So that's known as without replacement. And the second thing is with replacement. Suppose if I pick this slip D, okay, see the name in this and again put it inside that same jar. So then it will be called as what? With replacement. Don't we have this? We have seen this many times, right? With and without. Whenever I take any slip, I don't put it back in that that box or whatever it is, right? So that is without. And this is with. We use the term infinite population now because this infinite population term is asked in the exam. When we are talking about a population that could not be enumerated in reasonable time period. Now what do you mean by this? Infinite means, what do you mean by infinite? Suppose if I say 1 lakh population, even I can call that also infinite. I say 1 crore population, I can call that also infinite. Although it is countable. Infinite, what is the real meaning of infinite? Which cannot be counted. But if I say 1, I'll tell you, okay, tomorrow I'll tell you. You go and count the entire population of the city, wherever you live. Is it possible? That becomes infinite for you within reasonable period of time. Okay, so it cannot be determined within reasonable period of time, right? Thus, we use theoretical concept of infinite population as an approximation of a large finite population. Approximation of large finite. Got it? If my population is too used to be done in a survey, so okay, I'll give you one more example in this. I'll tell you what you do. You do the survey of 1 lakh people in 2 days. 1 lakh people in 2 days survey. Go and ask each one. It's not possible. That's a reasonable period. So that becomes an infinite population for that 1 lakh people for that 2 days. But if I ask you the separate question, now same 1 lakh population, I'll tell you to do the survey in, let's say, 10 years. 1 lakh in 10 years. Then it doesn't become an infinite population because there the time period is huge. That's the logic. Okay. So there is nothing called as absolute infinite or finite over here. Okay. Systematic sampling. In a systematic sampling, elements are selected from the population at a consistent level that is measured in time, order or space. Now consistent level, what do you mean by this? Just now I told you when I gave you that separate this slide I showed you. Every 5th student in the class of 60 students, every 5th student will stand in a row and every 5th student will come out. So that's known as systematic sampling. So consistent, okay. Systematic sampling differs from simple random sampling that in each element, in that each element has equal chance of being selected, but each sample does not have an equal chance of being selected. Now, this is a problem with systematic. And this question comes in exam as a complete the following for 1 mark. Systematic sampling differs from simple random sampling that each element has got an equal chance, because I don't know which element will stand on the 5th of this means whenever I tell them to stand in the row, who will be standing 5th? I don't know. So that means each element has got an equal chance, but each sample does not have, because the one who will be standing 4th, he will not get selected. So each sample does not have an equal chance in systematic sampling. In systematic sampling, there is a probability of introducing an error into the sampling process. The system chosen may cause a problem. Now, these are all the complete the following questions or match the following questions. They'll give you systematic sampling. Then on the other side, they'll give you the probability of introducing an error. This is what is an important part in the systematic sampling. Remember this from the match the following or theoretical part. Okay. Advantage. This method may require less time and sometimes results in lower cost than simple random sample method. Right? Because systematic sampling, obviously we are not telling all the 60 students to stand and select randomly. We are telling every 10th or every 5th. So it means it will give me a fair chance and it will be fast over here. Okay. Stratified sampling. To use stratified sampling, we divide the population into relatively homogeneous groups called as strata. Now, what do you mean by this homogeneous? When we divided those students 40 to 50%, 50 to 60%, right? We did it just now. 40 to 50, 50 to 60. So what were we doing? What did I tell you at that time? Suppose somebody has got a percentage of 40 to 50. They will think in the similar way. But the one who has got a percentage between 90 to 100, the thinking of these two persons, these two groups will be totally different. But within the groups, they will always think similar. So this is known as homogeneous. Thus, when we use the following of the two approaches. So first, we'll divide them into separate strata. Then either we select at random from each stratum a specified number of elements. Specified means what? I may tell that from 90 to 100 we'll select 5 students. From 40 to 50 we'll select 10 students. So I might have already decided. That's why. Come back to the first definition of that sampling distribution. Predetermined. Okay. I'll say 90 to 100 I want 5 students. 40 to 50 I want 6 students. 50 to 60 I want 10 students. It will be determination from my side. That is one way out. And second way out is we draw equal number of elements from each stratum and give weight to the results according to the stratum's proportion in the total population. Okay. So I can draw specified number from each separate group, or I can draw equal number. Every group 40 to 55, 50 to 65, 60 to 75 and so on. So equal number or specified number. When to use stratified sampling? When do you use this? Stratified sampling is used is an appropriate when the population is already divided into different sizes. Means already I have divided 40 to 50% marks, 50 to 60 I have divided. Then stratified sampling is useful. Okay. Example, middle class, upper class, lower middle class. So I have divided this already. So then stratified sampling is of use. According to age, race, gender or any other stratification, age groups may be 13 to 20, 20 to 30, 30 to 40 and so on. Right? The advantages of stratified sampling are that when they are properly designed, they more accurately reflect the characteristic of the population from which they are chosen than any other kind of sample. So basically it is correct. Suppose if I choose 20 to 30 age group, so that thinking will give me the correct picture. Suppose if I want to design a jeans, okay, jeans pant. So which group thinks in what way? For that I have to divide it into various age groups and then I'll get the real answer. So that is that there the stratified sampling will be of best use. Cluster. We divide the population into groups or clusters and then select a random sample of these clusters. So first we'll divide them into these groups or clusters. What did I say earlier? It is similar to that of that regional geography based Goa, MP, UP. We assume that these individual clusters are representative of the population as a whole. Now, how do we do this? Now, this again, you'll get this. What did I say earlier? Goa, MP, UP. We take a city map and divide the territory into blocks, right? So, instead of city, I can take India map complete and divide it into various states. So, it means again, we are coming to geographical distribution and then choose a certain number of blocks for interviewing. Out of this, I'll choose which state should I interview the best or which area should I interview the best. Every household in each of these blocks would be interviewed, right? Comparison of stratified and cluster. Already I have given you. We use stratified sampling when each group has a small variation within itself, right? Stratified 40 to 50%, 50 to 60, 60 to 70. But there is a wide variation between the groups, right? 42% thinking, 40 to 50 thinking differently than 80 to 90, right? We use cluster sampling in the opposite case. When there is considerable variation within the group, Goa, MP, UP, but groups are essentially similar. Means in Goa also I am having 80 to 90%, in UP also I am having, in Tamil Nadu also having, everywhere, right? Basis of statistical inference. Simple random sampling, systematic sampling, systematic sampling and stratified sampling and cluster sampling. So basically systematic, stratified and cluster sampling, okay, attempt to approximate simple random sampling. So understand this concept. This concept is, let me cancel this part is a heading. Okay, yeah. So systematic sampling, stratified sampling and cluster sampling attempt to approximate simple random sampling. This is an exam question. In exam they will ask you systematic sampling, stratified sampling and cluster sampling will attempt to approximate dash, and then the answer will be simple random sampling. Remember, these are the practical questions asked in the exam. The process of making statistical inferences is based on the principles of random sampling. Very importantly, remember, simple random sampling is the best sampling available in throughout the world. All these systematic, stratified, cluster are taken later. They are an approximation. Now I'll come to the second part. This was all that probability. Now this is non-probability. Now what is this? Let's see. Purposive sampling, also known as judgmental, selective or subjective sampling, is a form of non-probability sampling in which the researchers rely on their own judgment when choosing the members of the population to participate in the survey. So this is all judgmental. Suppose we see in that what TV shows, singing competition, dancing competition, what Naj Baliye, right? All those are there. No? What do we see in that? There are judges. Judges have their own judgment. They are the learned person. So in form of non-probability sampling, where the researchers rely on their own judgment, own knowledge. So this is judgmental sampling. Non-probability sampling is a branch of sample selection that uses non-random ways to select group of people to participate in the research. Non-random ways, okay? It's based on the judgment, simply, completely on the judgment. Now some other samplings, and these are also judgmental only. Snowball sampling is a non-probability sampling method where new units are recruited by other units in form of to form the part of the survey. So this snowball is asked every time in the exam, every time. This is similar to that of MLM, multi-level marketing. You know that, na? You say you do one person, then that person will do three persons, those three will do again three, goes on and on and on, right? So that is the same way. Where new units are recruited by other units to form the part of the sample. Second is convenience sampling. Convenience is the cheater. Who is the cheater? Is a non-probability sampling method where units are selected for inclusion on the sample because they are easiest for the researcher to access. What do I mean by this? Suppose if you tell me to do the survey of 15 persons in the city, 15 persons. And what do? I sit at my home. Who will go, man? Who is near me? Neighbors. Bring all my 15 neighbors and my family members. So that's convenience. Okay, because they are easiest for the researcher to access. Quota is a non-probability sampling method that relies on the non-random selection of predetermined number of proportion of units. Okay, so non-random selection of predetermined number. Predetermined. Quota means what? Mumbai 100, this Delhi 100, this what UP 100. So quota means what? A quota is given to everywhere. Consecutive. This is a sincere guy. Sincere. This guy is a cheater. Convenience. And this is a sincere guy. It's very similar to convenience sampling, except It seeks to include all accessible subjects as a part of the sample, which sometimes are considered as the best type of non-probability sampling. So this guy won't stay at home. He will go to each and every accessible part. 15 people, I'll go to one corner, then other corner, then other corner, and then I'll select the 15 samples from there. So this is consecutive. Sincere guy. Okay.
Now let's study some case studies or numericals, we'll call it. Case studies means what? Numerical. One thing I'll give you very important about the numericals of time series. Firstly, there are 4 points which you have to remember. 4 points always. What are those 4 points? Summation x equals to 0. Your summation x should always be 0. Always, always, always. If your summation x does not come out to be 0, it means you have gone somewhere wrong. X will always be time. Remember this by heart. X will always be time over here. If x is even, multiply whatever is given by 2. This is the third point. If x is even, multiply by 2. And then B, how to find out? See here, this B we had seen in our correlation problem also. In correlation we had studied this. B we had that formula. What? Covariance of xy upon variance of x. Right? But here this is very simple. Summation xy upon summation x square. It is actually derived from that formula only. Okay? Because summation x is 0 over here, that's why B becomes very simple. Now let's look at the numerical. These 4 points, everyone got this? Summation x 0, x will be time, x is even, multiply by 2, and B equals to summation xy upon summation x square. So let's study now. Remember this third one, x equals to even, multiply by 2. Now look at this. A time series data for 9 years. 9 means what? Is this third point even? No. Odd. So no multiplication by 2. For the sale of the table by the furniture mart is given below from year 93 to 2001. So these are the sales. Find the linear equation that describes the trend of the sales. Find the forecast for the year 2003. So 2 questions are asked. So first you have to find out this equation. What do you mean by this linear equation? This linear equation means you have to find out y equals to a plus bx. Y equals to a plus bx. This is the linear equation which you have to find out. So what are the important points? You must remember these 4, and see these 2 highlights I am giving. Check if the linear equation is asked. Always you must focus. Otherwise what happens in the exam, they will ask you second degree equation and you will only focus on linear equation. Okay, don't do that. Check if the linear equation is asked. If it is parabolic or second degree, you have to focus on that. Thirdly, check the number of items, and if even, then multiply by 2. This already I have stated. Okay. So let's start now. Look at this. How to solve this? Firstly, what you have to do, write all the years. What are the years given? 1993 to 2001. See this, 93, 94, 95, right them down. Then find the mean of this, average. What will be the average? So if it is an odd number, then it's very easy. The central number will be the average. So 1997 is the average over here. So I'll write this mean over here. Then what do you do? Subtract each year from this mean. So 93 minus 97 minus 4. 94 minus 97 minus 3, and so on. Do it. Here you will see in the bottom 2001 minus 97, you are getting plus 4. Plus 3. Here it is minus 4, minus 3, minus 2, minus 1. Here plus 4, plus 3, plus 2, plus 1. So, and this is 0 over here. So if you do this and you do the addition of this x, this is called as summation x. So what did we say earlier? Summation x will always be 0. So that's why this summation x becomes 0. Now should I multiply this by 2? No. N is even? No. N is odd because it's 9 years. So this is my final x. This is what I have got is my final x. Now y. Y is given, whatever is given, write the same one. 175, 190, this is given over here. See this, 175, 190, 185, blah, 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 all these things. Okay. Just write them. Do the total of this y. Okay. Now, next part. Multiply xy. Similar to correlation. Multiply xy. Okay. So, x into y. Multiply this. Minus 4 into 175, minus 700. Minus 3 into 190, 570, minus 570, and so on. Okay. Do it for all. Similarly, x square. Look at this. 4 square minus 4 square minus 3 square. So square will always be positive. Let it be minus or plus. That's why you are seeing 16 over here and 16 over here also. 9 over here, 9 over here. So you'll do this total, you'll get it 60 summation. Now what is to be found out? Y equals to a plus bx. This is your final target now. Y equals to a plus bx. First find out b. What is the formula for b? What did I give you the formula? Summation xy upon summation x square. This becomes 0. Why? See this. I'll expand this. See, the b formula is summation xy upon summation x square. Why? Because actually the formula is n x bar dot y bar upon this. But x bar is 0 because your total of x is 0. So what is summation? What is x bar? X bar means what? Average. So this average also becomes 0. So now your answer is simply summation xy upon summation x square. This you already know. What is summation xy? Look at this. 119. Upon what is summation x square? 60. Right? So 119 upon 60. You will get this answer. 1.98. So roughly say 2. Okay. So roughly you'll be saying 2 over here. So now you got it B. Now what next? Use the same logic now of correlation. What was the formula for this? Y equals to a plus bx. So now what will you do? You will put y bar and x bar over here. Now what do you know over here? In this y equals to a plus bx. You know y bar. Y bar is what? This average y bar. See this. 1702 divided by 9. Right? So 1702 divided by 9. I might have done it over here. Okay, y bar. So here. Look at this. So 1702 divided by 9. This is my y bar. So it is 189.1. So y bar I got it. But what is x bar? X bar is 0. Right? Because what is x bar? Summation x, addition of x upon n. Addition of x is 0. So x bar is 0. So what does my equation become? Look at this now. A equals to y bar minus bx bar. Right? This equation y, I'll take, what do I want now? A. So I'll take bx on this side and apply bar to it. But x bar is 0. So a becomes what? A equals to y bar minus bx bar. That is, this is 0. So a becomes y bar. What is y bar? Average of y. What is average of y? 189.1. So that's why a becomes what? 189.1. So now I have got the answer. Y equals to 189.1, or you can write simply 189 plus bx 2x or 1.9x. The more accuracy you have, the more okay it is. Okay. So you've got the answer of the first line, first question. What was the first question? First question was find a linear equation. So this is what you have got it. Now forecast for the year 2003. So now what is x? X is 2003, but x is not 2003. What you have to do is first subtract this x from the average. See here, you'll have to follow the same rule which you have followed for others. So instead of 2001, write 2003. So subtract this, what do you get? 2003 minus 97, you get it 6. So 6 over here. So my x becomes 6 over here. Right? Because how did my x come over here? My x came by subtracting this number from this number. So 2001 minus 97, 4. So 2003 minus 97, 6. So I'll write this x as 6 over here. So that's why I got this x as 6. Shall we do it over here? Okay, let me show you. See this. So what is my answer over here? I'll show you over here. Let me bring it different pen because otherwise you'll get confused. So y equals to what over here? Y equals to 189 plus 2 into 6. Right? So 6 to the 12 plus 189, 201. This is what the answer you have got. Okay? 201 is your answer. So this is the way you solve this. Okay, simple. Now next one, case number 2. Now this is a bit tricky, separate one. Why? Because I have taken 4 numbers over here. See here, the data for the solar homes built in the region during the last 4 months is given. So 4 months of 4, why have I taken? Because there is something we studied. If x is even, multiply by 2. Now we'll apply that. Remaining things are same. Develop the data, develop the linear equation that describes the data and draw the line. So do this. Again, same sequence doesn't change. See this. 4 months, write the 4 months. Mean. Now see, look at this. Do you know the months? Year, earlier problem you had this year, 97, 96, all these things. Okay, here you don't have anything. So there you, what did you do? You found out the average. But here you don't have anything. So what do? You find out the average of this. See this, 1, 2, 3, 4. These are the 4 months. Find the average of this. So average will be what? 2.5. Center of these two. So 2.5, write it. Now follow the same sequence. 1 minus 2.5 minus 1.5. 2 minus 2.5 minus 0.5. 3 minus 2.5 plus 0.5 and plus 1.5. Now what did we say? Whenever the number of n is even, multiply by 2. So what we'll do? We'll multiply by this 2 over here. So minus 1.5 into 2. So it becomes 2x. So 2 into 1.5, that is minus 3. Here minus 1 plus 1 plus 3. Do the addition. Summation x is 0 again. So again the rule follows the same. Summation x will always be 0. Even if you do the addition of this, then also you will get it 0 only. But why do we multiply this? I have answered this at the end. Why do we multiply this x by 2? I have answered this at the end. End slide of this lecture is the same. Now write the y. Y is same. Whatever is given. What is given? See this 16, 17, 25, 28. 16 like this. Now same logic. Logic doesn't change. So x into y. Multiply this. 16 3s are minus 48. Minus, right? Minus 17 plus 25 plus 84. X square. Do the square of this. 9, 1, 1, 9. So same thing written over here. Now do the addition of all. Summation x square, summation xy, summation y, and summation x is obviously 0. So y bar you will require it. We saw in our earlier problem, we require y bar. So do it. 86 upon 4. So you'll get it as 21.5. So y bar you have got it now. Now what? Find the equation. Y equals to a plus bx. What is b? B is summation xy upon summation x square. Summation xy you know 44. Summation x square 20. So 44 upon 20, 2.2. 2.2. So b you have got it. What is a? Just now we saw it. A equals to simply y bar. So put the y bar. Y bar is 21.5. So this is your answer. So y equals to 21.5 a plus b into x. 2.2 into x. So you have got this. Right? Now if they ask you, have they asked you something? No. If they ask you, I have taken it over here, some example. Okay. Suppose if I want the sales in the 7th month. 7th month. Okay. This is the example I have taken, hypothetical example. If they ask you for example sales in the 7th month, so do the same thing. 7 minus 2.5. So it is what? 4.5. But here, even though we multiplied by 2 over here, similarly we will be multiplying by 2 over here also. Don't forget this step. You will be multiplying this by 2. Why? Because you have multiplied it earlier. Whatever you have done for the earlier numbers, do the same for this number also. Even in the earlier problem, I told you the same. Whatever you do to others, do it for the required problem, required number also. So 4.5 into 2, 9 you got it, get it. Okay, so x you got it 9. So put the value y equals to 21.5 plus 2.2 into 9, right? It is 2.2, not 2. It is 2.2, no? Yeah. See this. This is not 2. This is 2.2. So it is 2.2. I'll write it. Okay. Let me make the change over here. It is 2.2. Okay, into 9. So whatever answer you get it. I think so you'll be getting some different answer now because the figures have changed. Let me check. Okay. So what is the answer? 21.5 plus 2.2 into 9, right? Yeah. So 41.3. So you'll get this answer as 41.3. 41.3. This is your sales in the 7th month. If they ask you for the 7th month, then if they ask you for the 6th month, same thing. 6 minus 2.5. 5th month, same thing. Okay. Simple. Last case. Okay. Now, but here we are not stopping over here. You will say numerical end, lecture end. We are having some more theory also and some important numerical theory also remaining. A gas company has supplied the cooking gas to the city. This 4 years, 18, 20, 21, 25, 1996 to 1999, 4 years. Now look at the problem. The problems are different over here. First it is said linear equation. Done, simple. Second, look at this. B, calculate the percent of trend in this data. Percent of trend, something new. Next, relative cyclical residual, something new. This is also new. So these two terms have newly come to you. In which year does the fluctuation from the trend occurs? Is it same for both the methods? So there are two methods of coming to the fluctuation. I'll teach you that now. Look at this. Firstly, understand there are two methods to study the trend fluctuations. First is residual method. In this residual method will be divided into two parts again. Say this. Using this, one can isolate the cyclical variation component. Isolate means what? Like the COVID. What is isolated? Which occurs once in some times. Irregular trend. Once in some years, after 100 years, something occurs. So that will definitely isolate from our daily businesses, right? So residual method, this can isolate the cyclical variation. It is used for isolating the irregular trend. Okay. Now this method can be divided into two parts. What are those two parts? First is percent of trend, and second is relative cyclical residual. Percent of trend and relative cyclical residual. Okay. Now we'll study both of them. Okay. Percent of trend. Very simple. Nothing difficult as such. When the ratio of the actual values of y and the corresponding estimated values of y are multiplied by 100, we are expressing the cyclical variation component as percent of trend. So what is percent of trend? Actual y upon estimated y. Actual y upon estimated y. Okay. So y upon y star, I have written this as y star. So y upon y star into 100. When the percent of trend is calculated and plotted on the graph, we can observe the variations from the trend line. How does the variation occur? Okay, means for example, I'll show you. Suppose not only in this method, in the other method also, same logic. See this, if this is my mean and this is my variation, this is how my graph is going. So I can consider, okay, it's a regular business. But tomorrow if something like this happens, then what can I say? This is a COVID situation. This is to be isolated. This is to be removed. So my graph needs to move like this from here. Okay. So this, we are doing all this exercise for removing this. Okay. So got it everyone? Percent of trend means y upon y star. Actual y upon estimated y. Similarly this second one. Residual cyclical method. Same logic. No only formulas are different, but logic is the same. In this measure, we take the ratio of the difference between the y and the corresponding expected y and a y star. Means y minus y star means actual y minus estimated y upon estimated y. Look at this. Y, actual y minus estimated y upon estimated y. Both these methods are used. Okay. This method also, earlier method also, they will give you the similar answer. You'll see that now. So y minus y star upon y star into 100. Done. Now let's solve this numerical which was given. Okay. Now again plot this. Remaining problem is the same. Plot the 4 years, 96, 97, 98, 99. These are the 4 years. Look at this. This 96, 97, 98, 99 and all these figures 18, 20, 21, 25. Mark this. Say this. 96, 97, 98, 99. Average is what? 4 numbers. 4. So divide. What is the average? Center of these two, 97.5. Done. Now x. Now what do I do with x? Subtract it. 96 minus 97.5 minus 1.5. This minus 0.5 plus 0.5 plus 1.5. Done. But n is what? Even. So what will I do? I'll multiply this by 2. Why am I multiplying? Again I'll show you at the end. So minus 5 into 2 minus 3 minus 1 plus 1 plus 3. Do the addition of this. Now this is your actual x. Okay, this is your actual x. Got it? One second. So this is your actual x. I'll write it over here. This is your x. Okay. So y is what given, whatever is given. So do the same thing again. So xy multiply with xy first. Xy, x into y, right? X into y, multiply this. Minus 3 into 18, so minus 54 and do it for all. Similarly x square, this 3 square is minus 3 square is 9, 1, 1, 9. Same thing. Do the addition. Now this y, you find out the average also, because you will be requiring this average later. Now what do? We have to find out this percent of trend and residual cyclical. So we have to find out y star also. What is y star? Estimated, calculated y star. How will I get a calculated y star? See here, this is actual, whatever is given. And what is calculated? Use this equation, y equals to a plus bx. Okay. So first we will have to find out b. What is the formula for b? B equals to, what did we say earlier? B, summation xy upon summation x square, right? So 22 upon 20. Same problem earlier. So it is 1.1. What is a then? So a, you just put this value. In a, we have already found this out, because a is y bar. We have seen this, na, y bar. So what is y bar? 84. This is your total of y, right? 84 upon 4. So it is 21 now. So a is what? A is 21. So now what is the equation? Y equals to a plus bx. So 21 plus 1.1 into x, right? 21 plus 1.1 into x. So now we have got the equation for y. Now you can find out the estimated value of y. What you do, you put the value of this x, all the values of x you put it. Means what? This value of x, first you put it. See here, I have shown it over here. Expected y for the first year, 1996. Y equals to a plus bx, right? So 21 plus 1.1 into x was what? This minus 3. So put this value of minus 3, you'll get it 17.7. So this you've got this estimated y as 17.7. Similarly for the second one, put x as what? Minus 1. So 21 plus 1.1 into minus 1. So multiply this, do the calculations, you will get 19.9. Similarly over here, all the four you have got it. So now we have got the estimated value of y. Got it everyone? Simple. Estimated value of y, everyone got this. Now percent of trend. How do I find this percent of trend? What was the formula given? Actual y upon y star. So do it again over here. See this, percent of trend. For 96 I have found it out. What is the actual y? Actual y for 90, this percent of trend is 18 actual y. And what is the estimated value? Y 17.7. So I have done this over here. 18 upon 17.7 actual y upon estimated y into 100. So I am getting this 101.69. Okay. Similarly, now you look at this residual residual method also. What was that? Y minus y star. Actual y minus y star, right? Remember this? Actual y minus y star upon y star. So 18 minus 17.7 upon 17.7 into 100. Everywhere you have to do it. Why? Because it is a percentage. So you get this as 1.69. Now you see these figures over here. I have written it over here. See this 101.69 and 1.69. Similarly for others, actual y, what is that actual y? 20 upon 19.9 into 100. You will get this as 100.5. 21 upon 22.1. You will get it as 95.02. 25 upon 24.3. You will get this. Similarly for this also. 18 minus 17.7 upon 17.7 into 100. You will get this. So you are seeing all these figures. You can find it out yourself also. Right? So now we have got these trends. So from this trend, what can you say? From this trend, you can say that, see, the fluctuations in the first part is 101, second is 100, third is 95, and fourth is 102. So these three seem to be similar, 101, 100 and 102. But this figure is separate. This is like the COVID situation. I'll have to remove this. Similarly from the second method also. 1.69, 0.5, 2.88, and here I am getting minus 4.97. So this, both the methods will give you the same answer. Okay. So from here you can say that this year 1998 was, let's say, a COVID year. So that's why some difficult year. So that's why we'll have to isolate it. That's what the point is, right? And that is why we are studying this time series. Got it? Simple. Now we are coming to some extra theory, other parts. Means, what did I tell you just now, up till now? Up till now I have told you that the equation of y is y equals to a plus bx, right? This much I have told you. This is a linear equation. But if I want curvilinear, then what will I do? I'll add cx square. Cx square. Now this is a curvilinear equation. Sometimes they ask you this curvilinear also. If they ask you this curvilinear, then you'll have to solve this again. So B formula is same. B formula is same as it was there in the linear equation. Summation xy upon summation x square. So B formula is same. Only these two formula you'll have to add. Summation y equals to an plus c summation x square. And summation x square y equals to a summation x square plus c summation x raised to 4. These two equations are difficult. And they'll ask you in exam, they'll ask you for second degree trends, what are the equations used or which one is not used. They'll give you these correct ones, and last one they'll give you something wrong. X raised to 5 they'll give you somewhere. So that is not asked. So remember, y summation y equals to an plus ca summation x square, and summation x square y equals to a summation x square plus c summation x raised to 4, and b is same. Summation xy upon summation x square. Now solve this. Say this. Time is given 12, 13, 14, 15 and 16. Year is y is given, and this is time. This is given as a year. Okay. So what do you do now? You first find out the average. Okay. Same problem I have done, but in a shorter way. Okay. So what is the average of these 5 numbers? So no multiplication by 2. So directly 2014. 12 minus 14 minus 2. 13 minus 14 minus 1. This is 0, this is 1, this is 2. Right? So you have got x. So now m is what? Mean time. Just now we saw this 2014. This is the mean time. So summation of y is what? Summation of y means this total. Summation of y is 247. Now we have to find out this third degree equation, means second degree equation. So for that, what do we do? After coding x, summation x square equals to 10. What is this summation x square equals to 10? See this, x you have got it. Now do the summation of this. So summation x square means minus 2 square is 4, 4 plus 4 plus 1 plus 1. So 10. X raised to 4 is what? Again do the 4th degree. Because why do we require 4th degree? Because it is there in this earlier problem, right? If you check in this formula, it's there, x raised to 4. So you'll have to use it. So summation x raised to 4 is what? Minus 2 raised to 4, so 16. Minus plus 2 raised to 4, 16. So 16 plus 16, 32. Plus 1, 1 raised to 4 is 1, both, so 34. Okay. Then summation xy. What is summation xy? It's here. Get the same figures whatever we require. Summation xy we require. So what is summation xy? Multiply this x with y. So what is summation xy? 13 into minus 2, 24 into minus 1, plus this is 0, plus 65 into 1, plus 106 into 2. If you do the total of all these, including the minus sign, then you will get it as 227. Similarly, summation x square y. Why this x square y? Because you require it over here. See this. This you require. Summation x square y. Whatever is required over here, you will do the total. Keep it very simple. Okay. So now, summation x square y. Do the x square. Minus 2 square 4 into 13. So 13 4s are 52. Right? 52. So do this 52. Similarly over here, all these. Okay. So you'll get this answer as 565. If you do this, summation x square minus 2 square into 13 minus 1 square into 24. Right? 1 square into 65. 2 square into 106. So you'll get this as 565. Now you substitute the values in these formulae. So what is the formula? Look at this. First formula is this. Summation x square. What is this? I think so 247. So 247 is summation y. So summation y equals to an plus c summation x square. So summation y you got it, 247. An. What is n? N means how many numbers are there? 5. So you have to find out a now. Okay. So 5a plus 10c. What is this 10c? Look at this. C summation x square. Summation x square you know. You have got it already. 10. So 10c. Substitute this. You will get this from the first equation. This is which equation? Remember, the cursor which is moving right now is the equation number 1. Okay. Now equation number 2. Summation x square y. This also you got it. Summation x square y is 565. Equals to 10a. What is this 10a? See this A summation x square. So summation x square you got it already, right? This 10a plus 34c. So x raised to 4, okay, into c. So now we have got two equations over here. 247 equals to 5a plus 10c. 565 equals to 10a plus 34c. Now using these equations, you can find out, and b also you can get it. What is b? B is very simple. Summation xy upon summation x square. So xy I know. Summation x square 227. What is summation x square? 10. So it is 22.7. Right? So I've got b now. Now I want to find out a and c. How to find out a and c? Solve these two equations. Which two equations? These. Which one? This equation number 1 and equation number 2. Solve these two and you will get a and c. How to solve this? See this. Now this is a basic, but again I'll do it. Okay. So let me mark this. 1 equals to 247 equals to 5a plus 10c. Okay. And 2 equals to 565 equals to what? 10a plus 34c. So now what we have to do? We have to cancel a. So multiply this by 2. Okay. So this 3 becomes now 3 equation is multiply this by 2. So what is 3 now? 3 is 1 into 2. Okay. So what do you get now? In this 247 into 2, whatever it is, you can solve this. 247 into 2, let me have it the calci. Okay. 247 into 2, okay, equals to what is this? 494. So 494 equals to, now this will be 10a. We are multiplying this 5a. So 10a plus 10c into 2. So 20c. 20c. So mark this equation as equation number 3. Okay. So now do 2 minus 3. See this. I'll solve it over here. 2 minus 3. Do the subtraction. So 565 minus 494. Okay. 565 minus 494. So what is the answer? Minus 565. So you'll get it minus 71. So plus 71. 71 equals to 34 minus 20. Right? 10ab gets cancelled. So 34 minus 20. So 14c. 14c. So if you solve this now, you will get this c as 71 upon 14. So it will be something 5 point. 14 5 is 70. So you got this c as 5.07. So c equals to 5.07. Now substitute this c in any of these equations, 1 or 2, anyone. Substitute this. So if you substitute it in 1, so what happens? 247 equals to 5a plus 10 into 5.07. So you'll solve this for a then. A you'll get it as 39.3. So you've got all the three numbers now. 39.3, B is 22.7 and C is 5.07. Now you write the equation. Y equals to A plus BX plus CX square. 39.3 plus 22.7x plus 5.07 into x square. That is your final answer. Okay. So this is what is required. In exam, they will ask you this question. Second degree equations are nowadays asked many times. You have to remember just these three formulae. That's it. Okay. Now before going, let me show you how to join the batches. Importantly, I'll tell you, do join the batches because exams are near and the portion is very huge. Okay. So these have just started. You have not missed much. So join fast. Okay. Click on, go to Adda 24/7. On the Adda 24/7, in fact, I would suggest you to go through the app. In the app, you are getting 1% extra. Okay, using the coin systems. Go to JIB and CIB. Okay, then click on CIB June 24. Then you will see the various batches over here. Scholars CIB June 24. Click on this Scholars batch, or you can click on the resolution batch, the latest one. Okay, it's a resolution batch. You can click on this. Okay, click on the resolution batch. Then look at the discounts. See this 77% off. Don't go for 77% off. Click on buy now. Put the code I'll give you. Put this code Y432. Okay. Say this. Let this come. In the app, it's very fast. Okay. Put the code Y432. Click on apply. It is 79% off. Plus, if you are going through the app, you will get 1% extra. So definitely join this resolution batch. What do you get in this resolution batch? You get the ebooks, test series, online live classes, expert faculties, interactive classes, recorded videos are also available. You can join the Mahapack as well. In the Mahapack, you get multiple batches, okay, per subject. Multiple batches plus you get, say this. Click on this JIB CIB Mahapack. CIB Mahapack 2.0. So right now double validity is going on. So double validity means you buy for 6 months, you get it for 12 months. Okay. Now look at the fees also. Again, the discount is same. Click on buy now. Put the code Y432. Never forget this code. Huh? Click on apply. Okay, 79% off. Plus on the app, you'll get 1% extra. So definitely, I would suggest join this immediately. Okay, because the exam is near and you are getting huge discounts right now. Okay.